So that is preparing to go live, and I will try and find the link here in a minute. What I may do is just send that link and post it to you after class. All right, come on, come on. All right, there we go. Oh, maybe here it is. All right, and now I think we're back. And I'll put that in the chat. Oh, you already got it. Thank you. Oh, wow. Okay. Yeah. So feel free to watch the live stream instead of this, or just take a break and watch it later. Okay. Apologies. All right. So now let's go ahead and start here. Thanks for your patience. First day is boring. Okay. Sig Figs. Why should you care? Basically, we are scientists. We're going to communicate with others about numbers. The number of decimal places you include on a number says something to another scientist. So we want to learn how to write them correctly and when to include extra zeros and not. That's basically it. If you don't do that correctly, it can literally change the cost of an item when you send it to the shop. If you're an engineer and you design something and you accidentally change the precision, that can literally change the cost of the product by 10% or something. So we don't, or even more. Basically, okay, we need to do that. Here are the rules. And this is page 1 of the workbook. Now, the main rule that people have trouble with is this one. So I'll go through these first 3 quickly, and then we'll focus on this one. 3, 4, 5, they're significant. Anything non-zero. If there's a 0 between 2 significant numbers, they're also significant. Leading zeros to the left of leading zeros to the left are always not significant. I guess I should say never significant. And trailing zeros, it depends. So notice this big if. So on quiz day, you know I'm going to ask you a question about rule 4 because that's the tricky one. So let's take a look at some examples, and I'll try to show you on the screen here. All right. Oh. So give me just a second to line this up. Just finding out how high and low on the board I can write. Right about there. Okay. So let's talk about this number. And hopefully you could see that all right. Now, these numbers, they're at the left end. If you want, you can look at the rules. These are called leading zeros. They come at the beginning. These are trailing. Okay. This one, and this one, they're all non-zero. So these are significant by rule 1. Okay, that's this one, and this one. This one is a 0 between. So this is rule 2. That's also significant. Okay. So these are all significant. These are significant because this is between, also significant. Leading zeros, never significant. Trailing zeros, sorry, this is a long phrase. It's trailing. They're significant if at least 1 is to the right of a decimal. So in this case, these are significant. This particular number has 1, 2, 3, 4, 5, 6 sig figs. All right. This is not exciting stuff. It's just follow the rules, but it's important for reasons we will get to later. All right. So if you're going to do anything in the world with sig figs, with engineering or physics, you got to know this stuff, and it helps us avoid even worse stuff. All right. So any questions about that? And I see there's one in the chat. Let me check it out. let's see. So the first two zeros after the decimal aren't significant, even though, yes. So remember, leading. There's a difference. Trailing zeros, that's when you have to think. Leading zeros, never, never, never. Is that good, Jacob? Yeah, yeah. And so that's the thing. First, identify if it's leading or trailing. If it's leading, you don't have to think. If it's trailing, is at least one. Yeah. Yep. So cool. There's another thing here. I'm going to go ahead and do this, and feel free to add questions to the chat anytime. And obviously it's kind of hard for me to see everything at once, all your faces, all the whiteboard and this. So I'll get to it and periodically stop. But here's another weird case. All right. So these ones are trailing. All are not significant because all of them are to the left. Compare that to this. Now we see these two zeros. These are trailing zeros now. And now all three of these are trailing. These ones are significant. So notice the difference. Trailing zeros, if any one of them creeps past the decimal, they're all significant. If none of them, then no. And then, so yeah. So by at least one, I'm saying here, like if you had 403.00, or it could be just 0.0, as long as 10 is to the right of the decimal, all of those are significant. In this case, there isn't a single one that's to the right. Okay.
What about, I'm sorry, one question.
No, go for it. Go for it. Yeah.
What if there was a decimal point at that number at the end, the one you just erased? Wouldn't that make those zeros significant?
So here's a little secret about physicists. We hate chemists, but not really. We just like to tease them. So in chemistry, I know you've heard that means all of these are significant. I don't do it that way. All right, here, I'll show you how I do that in my class. And I keep this convention throughout the entire workbook. So if you know what he's talking about in chemistry, I don't know who that was, but this is a great question. Yeah, I'm with you. This, if you see that in a chemistry class, that means one thing. It's really confusing to tell where the sig fig is. So what I do in my class, and I do this in the workbook, and I do this in my solutions, and I do it everywhere, is I will literally write an underbar. So if I want this thing to be significant, all of a sudden an underbar is the trick I use to make something significant. Now, I just was, criticizing chemistry. It turns out I learned this trick from a chemist. So I don't really hate chemists. I just like to give them crap. All right. So, but the underbar to make a zero significant. And then, I don't know who asked that question because I was looking this way. Did that address your question?
Yeah, no, I just wanted to see if that was going to be on a test or anything, if the decimal was at the end of the number. Because I know most of the time you want to convert it to scientific notation to avoid that
sure
problem.
And yeah, and actually by the time we get through problem 1.6, we'll talk about the pros and cons of using scientific and others. That's actually the very next topic. So yep. Okay, so that's good to go. All right, very cool. Other questions on that?
So the zero that has an underbar has like decimal in front or behind it?
No decimal.
Oh.
It's just saying that this has one, it just says make this significant. So if I draw the underline, it says this is significant. So now that means if this is significant, I ask you this. Is this zero significant? Yes or no? What do you think? It's okay if you're wrong.
Yes.
Why?
Because it's at least one in front of the significant zero.
I would say it's between two that are significant. Remember rule 2? If this is significant and this is significant, that makes this one significant. Agreed?
Okay. Yeah.
So by rule 2 is how I would say it. Yeah, good question. And so this allows us to have extra zeros that are at the end that are still significant, even though they're to the left. Good. And then, so yeah, hopefully that addressed that question. And there's one to practice. If you look at 1.1, the question in the book, you could see that that is, maybe let's take a second. I know it's easy. It seems like it's just a few rules, but why don't you take a second to look at 1.1 really quick? Make sure you have the book in front of you or the file. Make sure you know where the solutions are. And let's just look at, for example, 1.1H has that underbar and it shows you what I mean. See if you could find that, find the solutions. If you're bored, you can skip ahead and do 1.2 or anything up to 1.16, okay? All right. And like I said, normally we'll have somebody else here, a student that you could chat with all the time during my lectures, okay? So I'm gonna get a drink of water. It'll get better. Another couple of weeks, we'll kind of be all coming together. All right. Okay. And then I'll just pause for a second and let you get organized. So this is the kind of stuff in the live stream you could double speed and get through fast, right? And anyone, if you're so bored out of your mind, if you want to go to the next page, 2, 3, anything up to about page 7, I think you can just keep working in order and go through them. And this is all stuff that you don't have to do outside of class. So the harder you work inside, the less you do outside is kind of how I see it. All right. So if you get a chance, you know where the reactions are in the Zoom, or if you haven't, maybe you could find that. If you were able to find the questions and the solutions, just maybe give me a thumbs up so I could follow that. Or if you've got your screen on, you can just stick a thumb up. Okay. It'll help me know who's able to find everything. Okay. Right on. Okay, cool. Looks like a lot of you are finding it, and that's awesome. I appreciate it. I will try to help anybody that can't. And by the way, at the end of class today, I'll stick around for some extra time to help you if there's questions we didn't get answered, or if there's something you want to ask after class. So, and I'll get my office hours dialed in as well. My kids just started online school, so I'm trying to deal with that, and I don't know what that's going to be like. So I'm waiting to get that dialed in before setting my office hours. I don't know. It's crazy. You know how it is. All right. I'm going to go ahead and ask you to pay attention to me now. And again, if you already know all this stuff, you can quickly realize it and just go back to working. All right. So I want to talk about scientific notation. So one of these questions, you notice I say, write these in scientific notation. It says, if you have trouble, try reading the next page. So I'm going to kind of go into this a little bit. We have scientific notation. That's discussed on the top of page 2. And then on the top of page 3 is going to be engineering notation. They're very similar, but there's just a couple of subtle differences. All right, so let's go and talk about scientific. And again, if you've already seen this, that's cool. You can just keep working and don't listen to me. All right, so. Let me make sure I'm still good here. I'm just checking to make sure I know where on the screen I can write and you'll actually see it, if you're wondering what I'm doing there. All right, so seems like I've been really rocking this number today for some stupid reason. I have no idea. Whatever. Here's a number. Let's say I want to write this in scientific notation. Hopefully you could see that okay. Yeah, all right. If you're able to see this stuff okay, just let me know in the chat or just give me the thumbs up. Again, okay, so hopefully the font size is big enough in the glare. All right, it looks like it's okay. At any time, if you can't read, just hit unmute and say, dude, I can't see what you're doing. Help me out. Or feel free to unmute at any time and shout at me, all right? Okay, so here we go. If I want to write this another way, take a look. Imagine here's where the decimal point would be. 1, 2, 3, 4. That means I could write this as 4.03 times 10 to the 4th. Now you might be wondering, why didn't I include these two zeros? Remember, these are trailing zeros. They're all to the left. These are not significant. Those two zeros are not significant, so I don't want to write them, because if I wrote them here, they would be significant, right? So it's important to know those sig fig rules before we bother doing this. So that's all I wanted to say about this. All right, you shift it 4 ways. Sorry, you have to shift it 4 to the left. That's 10 to the positive 4. You have to shift it 4 to the right. That's a negative 4. There's some examples there. Now let me show you another version. Same number. Engineering notation is a little bit different. You have to go in groups of 3 and you don't get a choice. So it's similar to scientific notation, but you have to do 3 bubbles at a time. So here's the decimal point, 1, 2, 3. That works. I try to go another 2, 3. 1, 2, 3. That doesn't work. There's no number over here. So I stop and I say, okay, for this one, I can only shift it 3 decimal places. So this would be 40.3 times 10 to the 1, 2, 3 bubbles. All right. And so that's how that one would work out. So this is engineering notation. Now, this is going to be on a test, and it's really important for cosmetics when you're doing presentations and things later on. But I just want to show you the right way to do this on a calculator as well. So my apologies if my calculator, I have to work upside down and backwards. So give me some latitude here. All right. If you have a calculator, you can use a graphing calculator for this class. Normally I make you use a scientific, but you're working at home. Life is hard enough already. If you want to use a graphing, go for it. I will tell you, if you're an engineer, to be licensed as an engineer, you have to use a scientific. So eventually you want to learn how to use a scientific calculator. So if you want to make that this semester, I would recommend it and just get that, figured out. But let's face it, maybe you're broke right now because COVID. So maybe don't get it. All right. So whatever you got to do, I understand. All right. So now in this case, let's say I type this number. Sorry, I think that was the number we used, right? Yeah. Okay. So in this case, the mode button makes it pretty easy. If I hit the mode button, right, you could see on this calculator, and your graphing calculator might look something similar, but there's right here, let me get a pointer. This second row here, sorry. The second row, notice there's normal, scientific, and engineering. So if you don't want to figure this out, just type the number into your calculator and change the mode. So what I'm going to do is it's really hard for me to do this right here. So I'm going to go down a row and then over. Let's say I want to go to engineering mode. I can do that. And now I can hit that second quit. And now I'll just hit enter. And notice it gives me the answer somewhere. Whoops. Oh, did I not hit the button? Sorry. Give me a second. All right. Oh, I forgot to hit enter. Sorry. So now I'll hit enter. Now I'll hit quit. And I'll type the number again. Sorry, this is such a boring part of the video. So now when I do this and hit enter, there it gives me the engineering mode and it gets it right. So if you don't want to learn this stuff, I totally get it. If you're an engineer and you just want to use your calculator, great. But sometimes it's just faster to use these bubble tricks, right? And so you could use that.
I have
Now, oh, go ahead. Go for it.
I have a question about the engineering method that you're showing us.
Yes.
So you said that it was three spaces down that we move it.
Right.
What if we would add another 0 to that? Would we just be?
Yeah.
400?
So let me just show you and see if I understand your question. So you're saying, what if I did this number right here, 403000?
Yes.
Okay. So then let's go and I see. So you go over 3, 1, 2, 3. It looks good. And now you're saying 1, 2, 3. The number out front has to be between 1 and 1,000. So if I go over another 3, I would get 0.403 times 10 to the 6th. It looks good, but this is wrong because it's not between 1 and 1,000. So my apologies. At the top of page 3, it says that the number you stick in front of the decimal point for engineering has to be between 1 and 1,000. Is that helpful? Did I address your question?
Yes.
So this one would actually be 403 times 10 to the 3rd. And this is, so notice this number is between 1 and 1,000, whereas this one over here is not. And so the trick for doing engineering is move over in factors of 3 until you get a number that's between 1 and 1,000, call it good, then double check it with your calculator if you're worried about it. Good on that one? I think that was that Lisbeth?
Yes.
All right, you good on that?
Yes, I am. Thank you.
Right on. Excellent question. And there's a couple of examples in there as well in the workbook. And so I tried to give you all those weird cases. So by doing the problems, you'll encounter every possible weird case I could throw at you on a test. So that's the importance of doing these problems. All right. Excellent. All right. Other questions? Well, I'm getting rearranged here. All right. Very good stuff. Oh, there's a whole bunch in the chat. Okay. Yeah, and I appreciate it. Sorry it took me so long to get to the chat. I was up the board. So let me see. The practical reason for the multiples of 3 is if all the engineers do this, there's just fewer prefixes we have to work with. And so I was actually going to talk about the prefix next. Esteban is totally right on it. Scientific is actually a lot easier when you're doing spreadsheets. So a lot of times what people do, screw it. I'm going to go right to it. Let me show you something here. And if you want to, if you have a book, turn to page 4. Page 4. If you have the file open, we want page 4, and I'm going to go to it on this screen. This is why we care about this crap, all right? We see that we need Sig Figs if we're going to understand how to write scientific properly. Okay, and then if we want to do engineering, cool. If you look at these 3 data sets here, this one is in scientific, and it looks like crap. Look at all these 3s, 4s, 5s. That's not great. By putting this in engineering notation, it's a lot easier to tell that these numbers are getting bigger because notice everything has the same power of 3 all the way down. That's one of the advantages of doing engineering. So when you look at this, you're like, oh, 1, 2, 5, 10, 20, 50, I see they're going up. That's not as obvious in this one. Finally, if we look at this, well, I know that 10 to the 3rd is related to a prefix called kilo. And so we're going to use that in a minute. And so notice these, instead of writing the 10 to the 3, I'm going to spit this out of here and write it in a prefix. And by doing that, these numbers are a lot easier to read for another scientist. So to be honest, here's how it works in the lab. You do all of your work in scientific notation because it's easiest to do math. Then you change it all to engineering, and then you get rid of the 10 to those with a prefix, and it makes it a lot easier for other people to see, even though it's more work for you. It makes you look better. It makes you more likely to get a job if you're doing an interview. That's it. It's just for looks, cosmetics. Sometimes looking good is more important than being good, unfortunately. Okay. Yeah. Okay. And then do the 1000. I get it. Yep. Engineers mainly use engineering notation. And then every once in a while, there are unusual exceptions where if, like, let's say I had added one more number to here that was like 2,000, right? 2,000 kilometers technically is not in engineering notation, but just to keep all the numbers similar, that's the case where you would actually write this as 2,000 kilometers instead of 2 megameters. Because, yeah, so every once in a while, when you're making a list of data, you kind of bend the rules a little bit. So going back to this question here, sometimes you might actually write this number, even though it's not true engineering notation, just because it might make your graph look prettier. Whatever. We'll get into that more in lab next semester, not now. So for now, just assume the rules are hard and fast, and we're not going to deviate. All right. So regarding the prefixes, remember, you could use this workbook during your quizzes, and you could use your homework problems that you've solved during your quizzes. So I'm hoping, whoops, shoot, I forgot to clear that. All right. So what I want you to do is actually do this stuff, and then you could use your notes. If you say, oh, this is very similar to problem 12.8, I'm going to look at that problem while I do my quiz. That's fine with me. I just don't want you talking to each other. So you can use the workbook, you can use the workbook solutions, and you can use your own notes. And hopefully during the quiz, that will help you succeed. If you don't do all the problems and you're trying to read the solution and use it, I think you're going to be way too slow to have any good grades. All right, here's what these prefixes mean. Let's maybe take a look at one. Let's look at this case right here. We're beating this one to death, so let's just finish strong here. Whoops, let me get out of the way. All right, so we already said that this is, and let's say this is meters. So this is going to be units of meters. We'll talk more about units probably the next day. Okay. So in this case, we have meters here. So we know that this is one, two, three. Let me do it like this. Okay, so I still have the units. Okay, so now what I could do is I could change this. If I read those prefixes that were on page 4, I know that 10 to the 3 is represented by kilo or lowercase k. It's kind of funny. You might notice usually all the positive prefixes have capital letters except for kilo. It's kind of a funny little idiosyncrasy. Whatever. This becomes 40.3 kilometers or kilometers. And notice it's just a lot easier on people to read small numbers than big numbers, and that's why we do this. So when you're given a presentation, this is a lot easier to look at for somebody in the audience than this. All right. Now, another thing is somebody else might tell you a measurement in kilometers, and then you would have to know how to do this all backwards. You'd have to read the prefix, say, oh, kilo means this, and do that. And then you could write this number, because again, if you're punching in numbers into your calculator, we need them without the prefix. If you're going to enter them in an answer, or if you're going to talk to somebody else, we need the prefix. It's just the way it is. So we're constantly flipping back and forth between prefix, no prefix, engineering, scientific, whatever. All right. So that's something I want you to work on. And I gave a bunch of different examples. Just to be lazy here, I'm just going to show you. There's a bunch of examples in the workbook that you can look at anytime you want. Now, I've been kind of keeping an eye on the clock, and I see we only have 10 minutes left. Sorry, I was a little out of the window there. So I want to actually talk about one more thing here, and maybe do a problem really quick. It's kind of tying this all together. Like, why are we doing this? What's the point? So let me sit down for a second. Get in here. Oh, let's see here. So I'm going to look actually at page 6 really quick. And I apologize. I went a little long today when we were talking about the syllabus. So it won't always be so bad. Scrolling. Here we go. This is the last thing I want to talk about. And normally we'll do a lot more problems in class. All right. So math with Sig Figs. This is one of the things that we're doing this for. So we want to know, if we do a bunch of measurements and do some work on them, we usually want to know how those measurements affect the output. If I have 2 sig figs on all of my inputs, how many sig figs am I going to have on the output? So if I do a bunch of measurements and I measure some time and I measure some distance, if I get 3 sig figs on all those measurements, do I always get 3 sig figs on the output? No. I'll say that again. If you have 3 sig figs on all the numbers that you put in, sometimes you get a different number of sig figs on the answer. And by keeping track of these and following these rules, we could save ourselves an even worse thing called error analysis and error tolerances. As an engineer, you'll get to that later. Sig figs is a shortcut to avoid full-blown error analysis, which is horrible, horrible. All right. So let me just show you. You can have the rules up on your screen if you want. I'm going to stop the share and work on the whiteboard. All right. All right. Well, probably right about there. So I'm just going to give you a couple of quick examples to show you why this matters. Let's say we're doing some math, and for some reason I say, oh, this thing takes 98 minutes and this thing takes 13 minutes. I hope that it's pretty easy to see that these are both 2 sig figs. Okay, 2 sig figs. When I add these, let's take a look. So I have 98 minutes plus 13 minutes, so I'm going to get a 1. Okay. Oh my gosh. I hope I didn't screw this up because I'm not thinking about it, but let's see. Let's double check. It looks good, right? So 10 would be 108 plus 3. All right. So now the question becomes, how many sig figs? Well, first I'm going to write the units, because we're doing physics, we have to worry about that. In math class, they never use units. In physics class, we always use units, or almost always. So now this is where the underline I was talking about earlier really comes in handy. I look at this number. Where is the doubtful figure? Well, I just keep going. This is the rightmost figure, right? This one is off in the ones column. This one is off in the ones column. So when I add them, I think it makes sense to say, well, if this one's off in the ones column and this one's off in the ones column, shouldn't this one be off in the ones column? Which means if this is significant, how many sig figs do you have? 3. Maybe you could understand this with another example. Okay, so that's one example, seeing how when you add, the number of sig figs could change. Let's say we have something else where we do one measurement that's 29 seconds. And let's say we take away 26 seconds. When we do a subtraction, we can see these upper numbers both have 2 sig figs. 2 sig figs. When I do the subtraction, I get 3 seconds. Notice this is off in the ones column. Ones column, ones column, ones column. We only get 1 sig fig. When you add or subtract, the number of sig figs can change. Okay? And then, oh, I see a chat there. Okay. Oh, sorry. Sorry, Elizabeth. I'm a little slow. I'll get better. Okay. It'll help when Memo is here. Memo is going to help us out starting Wednesday. All right. We got 5 minutes left. I'm going to keep rocking here. So one of the things that happens is sometimes you'll get a really complicated problem. Like, let's say we need to do, actually, I've got one written up. So I'll show you. I just want to show you right here, and let me get this out of the way. This shows you a math problem. And the idea here is I wrote out this math problem in 2 ways. And the idea is what I'm going to do is I'm going to underline the sig figs. Right here, because I did a division, maybe I'll do it like this. And I think I can actually, let's go a little bit bigger. There we go. Sorry, it's scrolling around. Okay, here we go. Okay, right here, both of these numbers have 2 sig figs. So the output has 2 sig figs, but I don't round. These two numbers had 2 sig figs, right? 5 and 5. So I'm going to have 2 sig figs. I don't round. Another division, multiplication. When you multiply, divide, you keep the number of sig figs, 2 sig figs. Generally speaking, you keep the smaller number. So if one of the numbers has 3 and one of the numbers has 2, you would keep 2 sig figs. You keep the crappier number, all right? So now I'm going to do this subtraction. Rather than try and do that in my head, I'm literally going to write it like this. Sorry, it's so slow. And anytime I do one of these problems where I have to keep track of sig figs, I literally write it out. And that's where I get this 0.45, right? And now if I look at those sig figs, this one had 2 sig figs. This one was off in the second sig fig. This one should be off in the tenths column. So notice we lost a sig fig. When you do the squaring, you multiply it, you keep 1 sig fig, et cetera, et cetera. And what we see is if you don't do this math correctly, by keeping the sig fig column marked and not rounding, you get these big differences. If you do this and round at every step, you end up screwing up by 20%, which that would be a big deal. We're kind of running out of time here. I think that's pretty good. Let me stop for a second and see if there's any questions here. I think what I'm going to do now is actually stop the live stream, but stay on and answer any questions you want. And at this point, I will put it in the chat. Apologies if the computer is lagging. I know that happens sometimes in the chat. So do any problems up to 1.15? So if you could do any of the problems in the workbook up to 1.15, and for the first few, use the solutions, follow along. But by the time you get to the last 1 or 2, try to not use the solutions and see if you can get it without it, okay? Work with a friend, right? Make it more fun, have a group work. And so anything you could do to make this more fun would be a good thing. So use the solutions for the first 1 or 2 so you get started and get the momentum. And then stop using the solutions because you don't get solutions for the quiz questions. All right. And did I stop the?